Hi guys, it's me again, M. Udomsak Rakwongwan for Mathematics for Engineering 3 International Programs, Kasetsart University. This is the fourth chapter of the Mathematics for Engineering 3, which is the systems of linear differential equations. Guys, if you remember, we did linear differential equation in chapter 1 and 2, right? But today we are going to be doing what is quite similar to chapter 2. Okay, so if you don't remember what chapter 2 is, we solved the higher order ODEs, right? And we have three different cases. If you remember, first we look at the homogeneous equation, and we have three different cases, which are the distinct root, the repeated roots, and the complex roots, right? And after that, we did the non-homogeneous case, and we used the variation of parameters, if you remember. Okay, but if you don't, no worry. Okay, we're gonna do what is quite similar to that today. Okay, so let's get started. Here, that's the name of the chapter, the systems of linear differential equations, and that is my name and my email. Okay, I think you all are already familiar with me. Okay, first I'll give you the outline of the chapter. First, we'll talk about the introduction. Okay, what is systems of linear differential equations? Okay, what are they? And second, we will talk about the first order homogeneous. Okay, the second chapter would be about the homogeneous. Okay, the second section would be about the homogeneous, and we split that second section into three subsections, which are the distinct root, the repeated roots, and the complex roots. Okay, we did something similar in chapter 2. Okay, and after that, we will have a look at the non-homogeneous systems of linear differential equations. Okay, and that is our outline. Okay, so today in this video I'm going to be talking about the introduction. Okay, we considered systems of linear differential equations with constant coefficients. Okay, and there are two or more dependent variables. Okay, guys, there's a typo here. It's dependent variables, and there's only one independent variable. Okay, in our course, we usually denote the single dependent variable by t. Okay, it's not necessary, but to make it easy, in this whole course we usually denote the independent variable by t. Guys, if you don't remember what dependent independent variables are, just go back to the first chapter. Okay, the first video when I gave you the introduction to the ODEs. Okay, so let's look at these examples. Okay, the examples. Before we go to the examples, let's sum it up again. The systems of linear differential equations, okay, with constant coefficients, they are actually, equations, okay, many equations with two or more independent variables and only one independent two or more dependent variables and only one independent variable. Okay, let's look at this example. Here's a typo again, my bad. Here's y prime. Okay, so here the dependent variables are x and y. Okay, when I say two variables, I mean two dependent variables. Okay, so and the independent variable is t. Okay, As I told you, we usually denote it by t. And when we say x and y are dependent variables, it means that x is actually a function of t or xt, and similarly y is also a function of t as well. Okay, so x and y are function of t. That means, that's why we say that x and y are dependent, because they depend on t. Okay, that's why they are dependent variables. Okay, and that is we have the first differential equation, right? The second differential equation with two dependent variables, and these two equations are called a system of linear differential equations. Okay, the second example here is, again, it's three dependent variables. Okay, in this case they are x, y, and z. Okay, they are x, y, and z, and again the independent variable is t. Okay, and we have here the first equation, second equation, and third equation, which means that this is the system of linear differential equations. Okay, and the system has three equations. Okay, three differential equations. And the next one here, when I say variable, I mean dependent variables, are x1, x2, and x3. Okay, and the independent variable is t. Okay, and we have the first equation, second equation, and third equation. Guys, when I say x prime here, it means dx by dt. Okay, and y prime is actually dy by dt, and z prime is dz by dt. Okay, and similarly, guys, this one, it would be dx1 by dt, because we have only one dependent variable t. Okay, so when you see any derivatives, okay, x prime, y prime, z prime, x1 prime, x2 prime, any of them, they are derivatives with respect to t. Okay, they are derivative with respect to t. Cool? Okay, let's go to the next topic, the matrix form. Guys, when you have systems of, differential equations like this, like, two variable, three variables, those are the system of differential equations. It is sometimes easier to write those equations down in matrix forms. Okay, for example, look at the left hand side, the regular form. Okay, here there's no matrix, right? The left hand side, this one. And as you can see, we have this is the first variable, the second dependent variable, and we have xn. So here x1, x2 to xn are dependent variable, and this guy t, b is a function of t, so bt can be like 5t plus 5 or e to the t, or stuff like that. So b are the function of t. Okay, so t is the, again, independent variable. So here we have n equations, right? We have the first equation, second, third, until the nth equation. Okay, and that is the regular form. By the way, we call this system of differential equations homogeneous if b1 t, b2 t, blah 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 until bnt equals to 0. Okay, if they are all equal to 0, which means that this disappeared. So if they are all equal to 0, we call the system homogeneous. Okay, and as you can see, we can write the left regular form to the right matrix form, and it's gonna be in this form, which is x prime here, guys. Don't forget x prime here is a vector. Okay, x prime equals ax plus b. Okay, when x prime is this guy, okay, and a is this guy, this is a, and b is this, and of course x is this. So if you look at the first row of the matrix, you would get x1, right? The first row of this, you would get, if I look at the first row, okay, the row in this way, if I look at the first row, I would get x1 prime, right? Because it will be the first element of x prime. And here I would get this row multiply this vector, okay, a prime x. So I would get this row, and then I plus b, so I would get this one, the first row. Okay, so these two forms, they are equivalent. Okay, and if b here is the 0 vector, okay, if it's 0 vector, we call it homogeneous, which is the same as this. Okay, it's homogeneous if all the b's are 0, and if all the b's are 0, the vector b here must be the 0 vector. Okay, and in that case we call this equation homogeneous. But if one of these element, at least one of these b's is not 0, the equation is non-homogeneous. Okay, let's look at these examples. The first example, write down the following system of linear differential equations in matrix form. Okay, so here is x prime equals 3x plus 4y, and then y prime equals 2x minus 3y. And here I can write down as x prime y prime equals 2, 4, 2 minus 3, and then xy, right? Because if you multiply this matrix, you would get 2x plus 4y, and then 2x minus 3y, and this is what you would have. Oops, sorry, it's a typo here. My bad, it's 3 here, not 2. So you get this, and the other one, you would get this. Okay, so we can write this down as x prime equals a x plus b when x prime is x prime y prime. This is the big X though, and the big X here is xy, and the matrix A is 3, 4, 2 minus 3, and the matrix B here is 0. Okay, don't forget guys, here it can be plus 0 and 0, and this equation is called homogeneous because the vector b here is 0. Okay, next example. This is a system of linear differential equations when we have 3 variables, right? They are x prime, y prime, and z prime. So this equation can be written as x prime, y prime, and z prime equals 3, 4 minus 5, 1 minus 2, 7, 2, 5, and minus 1. And here you have x, y, z, and that will be plus 2t e to the t and t squared. Okay, I hope you don't have issues with the matrices, right? These are just the matrix operation. So these guy, they are this guy. Okay, and here 1 2 3 4 5 6 7 8 9, they are 1 2 3 4 5 6 7 8 9. Okay, and here they are this term. Okay, so this matrix can be written down as x prime equals a x plus b, and the x prime would be x prime, y prime, z prime. X is x, y, z. A is 3, 4 minus 5, 1 minus 2, 7, 2, 5 minus 1. And B would be 2t e to the t and t squared. Okay, and as you can see, the B here is not zero vector. So this equation is non-homogeneous. Okay, so that's it guys for the first video. So let me sum it up. First, we talked about what systems of linear differential equations are, right? We have one, two or more dependent variables, and we have only one independent variable, usually denoted by t. Okay, and then we looked at a couple of examples of the systems of differential equations. Okay, and we learn how to write them down in the matrix forms. Okay, in the next video we're gonna learn how to solve them. Okay, and we will begin with the homogeneous system of differential equations. Okay, see you in the next video guys. Bye bye.